Hello everyone. So today we're going to look into hyperbolic what called functions. Okay, so want to know how the shape what called looks like, and want to know also how the A affect the graph, how the Q affect the graph. How do you know which one is an asymptote? How do you know where is the graph increasing, where is it decreasing? How do you know also the equation, how to find the equation of axis of symmetry, and also finding the equation of the hyperbolic function given a point. Okay, so let's just dig in and see how much we have today. You know how I want to start my classes. There are the questions. Try them. If you can't get the question, if you can't get these answers, please, this class is for you. Listen carefully and come back and answer what call the question that we have there. Okay, now let's dig in and find out. So hyperbolic function. So in this case, we are going to look for we need to understand the shape. So let's just talk of the mother graph. The mother graph is y equal to 1 over x. Okay, so in this case here, the shape of the graph, this is the shape of the graph, okay, of our mother graph. So where we have got, let me just put a there. Let me put a there, okay, a over x. So now the shape of the graph, it shows that it doesn't touch the y and x intercepts, y and x axis, okay? So it means that these two graphs are these two lines here are your what you call asymptotes. So we have got asymptotes here for this graph, asymptotes here. Asymptotes are just points or lines that are just approached but not touched by the graph. So in these points are y equal to 0 and x equal to 0. So it means that your graph does not touch the y-axis and also the x-axis. Okay, so given the A, when A is above 0, that's where we find our graph. So we find our graph in the first quadrant and in the third quadrant. What about if A is less than 0, meaning to say it's a negative? When it's negative, when A is negative, it means that it's a reflection along the what called x-axis. Okay, so it's a reflection along the x-axis. So this is what we have here. So this is for A less than 0. So when A is negative, we find our graph are looking like this. Okay, so this is the reflection here, and also the reflection here along the x-axis. Okay, that's what we see. Let's just have an example here of maybe two graphs that we can draw, and also how also A affect the graph. So A also stretches the graph. So let's just look at this and see. So let's have a graph of y equal to 1 over x, and also y equal to 2 over x. Okay, 2 over x. And again, let's also talk of the negative part, where y is equals negative 2 over x, and also y equal to a negative 4 over x. Okay, so I want to see how if we had to increase the A, what happened? And also if it's negative, what happened? At least now we know the shape, actual shape of the of the graph. Now let's see what we'll have here. So we have got our y-axis, we've got our x-axis, and we know that for this graph here, on its own does not touch the y-axis and also the x-axis. So now here's the shape here of the first graph that we have there. So we're gonna put it, let's just put it in blue. So it's gonna be like this. Okay, it's in the first quadrant and also in the third quadrant. Why? Because of the sign, it's positive. Okay, then what about in terms of the 2x? 2x now is a stretch. So what we see is that it's actually a bit far from the x-axis. So when you increase the value of of A, you're actually moving it away from the x-axis. So you're stretching it and it's moving away from the x-axis. So here is our graph here. So we can label our graphs now. This is y equal to 1 over x. This is y equal to 2 over x. And also this is y equals to 2 over x and y equal to 1 over x. So you can just label, you only label one of them. You only label one of them and don't need to label both of them this side, okay? Okay, now let's look at the one down here where we have got negative 2 over x. Let's also see how it affects. Now we know that 2 is less than 4, so we expect 2 to be actually underneath here. And also this is the graph of the 2. And can you see what my graph is doing? It's just approaching the x-axis and also the y-axis. It's not touching it. Okay, now let's look at the one for, what is it? For the one which is straight, which is the 4. The 4 is a bit far from the x-axis. So unless if you are asked to draw these graphs on the same axis, so that's where you can worry. But otherwise, if you are just drawing one of them, there is nothing, there is no measurement here to say we are seeing how far it is from the x-axis. Just make sure that it does not touch the y-axis and also the x-axis. Okay, that's all what you need to know. So this is y equal to negative 4 over x, and this is y equal to negative 2 over x. So you know that whenever you see a negative on this graph, it's in the second quadrant and fourth quadrant. So negative, second and fourth. Then the positive is first and third. That's all what you need to remember, guys. Now let's look at when we bring in the q now. What will happen if we bring the q? Now, we want to know the effects of q. Q, this affect what we call up and down. So this shift your graph up and down. Okay, so it shift up and down. And when it's shifting up and down, what is it changing? It's gonna change the new x-axis now. Are you understanding? Okay, now let me explain this to you. Let's say here, if we are to if your q is negative. If your q is negative, we are moving our graph down. So it means that what is it in this case here? What do we have here in this case? We are moving graph. So when you move the graph, it means that we're going to have, let's say we move it by q units up. Let's say this is our q. It means that our graph in this case, if it's gonna be, if it's positive, we will find it in this area here. But what we'll see here is that it's gonna be in this what we call quadrant. But can you see now, we now have the x-axis. So we now have the x value. So it means that the new asymptote here is y equal to q. So now let's talk of new asymptotes. New asymptotes here is not approaching y-axis. So it means that the new asymptotes here are still x equal to 0, which is the y-axis. But now in terms of the x-axis, is now y equal to q. So q now is our new asymptote. So remember, it's now touching the x-axis. So, but now it will only approach the q, not touching it. Okay, let's now put this into what we call a practical. Let's give an example here. Y equal to, let's say 2 over x plus 3, okay? And also let's have graph of y equal to 2 over x minus 3. Now, if we are to have something like this, let's just draw the first one. The first one here is gonna be like that. Let's put negative here. Now, if it's in the first, what is it? The positive here, it's in the first and second. So what the 3, we're just gonna come here and put the what is it? Our line there. This is 3. And now when we have this, we can now draw our graph. It's in there. And also touching the x-axis. So now if we are to sketch, if you are someone who is sketching this graph, you need to find what we call the x-axis. Now, how do you find the x value? You make y sub the formula. So you'll be looking for the x-intercept in this case. So x-intercept, y equal to 0. Let's look there. 0 is equals to 2 over x, what call plus 3. Then we take the x there, it's going to be 0. So it's going to be what call 3x is going to be equals to -2. Then x is going to be equals to -2 over 3. So there is -2 over 3. That's what we see. That's where it's passing. So you must always remember, whenever you are crossing the x-axis, you must make sure that you find that value and know where it cuts the graph. Now, what about in this case here? In this case here, we are actually finding something different here. Because of the negative, we know that our graph should be in the second quadrant. And what? Let me just remove this for now. Let's look at the asymptote. Okay, asymptote is -3. So let's put -3 there. So -3. Then we always have to remember to label our x and y. Our x and y whenever you're drawing. Please, guys, don't forget. Now, there we have our origin. We have our origin, and we have the origin there. Okay, now, so to draw this graph, we know that it's negative. So it means that in this case here, it's going to touch where? Where does it touch? It's going to touch your x-axis there. Okay, and also it's going to be there. So in this case here, you will be actually asked to find the x-intercepts again, because remember, it's now the asymptote now is, what is it? It's y is equals to -3. So here in this case, you'll be asked to find what is it? What is the value of x? Now let's try to find that value of x. What do we know? We make y equal to 0. So it's going to be 0 is going to be equals to -2 over x, what you call plus minus, what is it? -3. Then we take what is it? We're gonna make what is it? We can take this whole thing here, this side. It's gonna be multiply here. It's gonna be 0 equal to what is it? -2 minus 3x. Then we take the 3x there. 3x is going to be equals to -2. Then x is going to be equals to -2 over 3. So again, here it's going to be -2 over 3. That's where it's touching. Okay, so you can see how this graph is behaving. It's going to be what is it? On the negative like that. Okay, so I hope you understand this concept. For now, we are only looking on the effects of Q and A. So now I think we understand that that's the shift that we're talking about. If you have to shift it up, if it's positive, you shift it up. If it's negative, you shift it down. Okay, now let's move on to the next slide and see what we have. Now, there's another thing that we understand, that we need to understand. So, like for example, here we need to understand the axis of what called symmetry. So, axis of symmetry is where the line that divide your graph into mirror images. So here we have got the y, we've got the x. So if we are to look for 1 over x, let's just talk of 1 over x. 1 over x, okay? So 1 over x, so it means that here in this case we're not having anything, maybe just a over x. If it's a over x, so y equals a over x, we know the graph, how the graph behaves. The graph behaves like this. Okay, this is the graph, and this is the graph. Let's also look at the one for the negative, where a is negative. Now, in this case here, what we need to understand is that the axis of symmetry that we're talking about here, these are the lines that divide your graph here into 2 mirror images. So it cuts your graph. So in this case here, whether it's a negative or a positive, what we know about the axis symmetry, the positive one, the positive will have a positive gradient. So what you will see is that here is going to be the first one, which is y equal to x, and this one here is going to be y is equals to -x. So we've got only these two axes of symmetry. So we've got the positive one, so positive equation, positive axis of symmetry. This is the one we are saying is y equal to what is it? X. What about the negative? This is the one that we are saying y equal to negative x. Then you are done. But now let's say you now have the q. We now bring in the q. Now, if you are to bring in the q, what will happen now? How will your, or what call it, your graph, what call it, react? Let's now have our graph. Let's have a new graph here. I'm just going to draw a small one here. Okay, a small one, and where we are saying we bring in the q. And when we bring in the q, let's just talk of this q as what call is maybe somewhere here. But what I want you to understand, don't worry about the q. We are not stressed about the q here. We're not stressed about the q, that what is the value of the q. But what you just need to remember is that how do you deal with that situation now? So here we have got the q. Now, when we are to draw our graph, let's draw our graph there. It's going to be, maybe in this case, is the positive one. It's a positive gradient. So we have something like this. Then here is the negative gradient. So no matter where the q is, what we will see is that this is going to be our axis of symmetry now. Two axes of symmetry. Can you see what we have done to this axis of symmetry? It's have shifted. So always we have two axes of symmetry. You must remember you have got two axes of symmetry, the positive and the negative one. So here we have got the axis of symmetry. The positive one is y equal to x plus q, and the negative one is equals to y equals to negative x plus q. Okay, so for example, let's talk of the graph of maybe let's say the graph of y like that. No, it's fine. Let's say this is our axis. This is our q. Let's say our q here is 4, and we have got the y and x. Okay, then we are saying this is our new our graph. So in this case, our graph can be let's say this graph is y is equals to 2 over x plus 4. Now, if it's 2 over x plus 4, it means that the axis of symmetry here, in this case here, the axis of symmetry, I'm just going to put it in short like that. Then again, you must know that we have the positive. The positive in this case is going to be equals to y equal to x plus 4. That's all. Okay. Then the negative one, for the negative, is going to be equals to what is it? Y is equals to negative x plus 4. That's all, guys. You must not stress about anything in this case. Just know that these are your axis of symmetry, and that's how you get your equations. Okay, so if ever whenever you have a q, just know that if they want the negative one, you put the negative x plus that particular value. If it's a positive one, you also do the same. Okay, so in this case, I think we are done. So if ever maybe we're having a negative here, in this case, we're going also to say negative x negative, I don't know what value, or x minus whatever the value is, which is the q. Okay, so I hope you are understanding so far. Now, let's move on to the domain and range. Domain and range. And remember, the domain from our previous class, domain, it has to talk about the x values. Okay, it's define your x value, and your range is your y values. Okay, it's your y values. And when you are saying decreasing, it means that it's a negative gradient. And when you are saying increasing, it means that it's positive gradient. Now, good thing about this thing is that in terms of the gradient, your graphs will have same gradient throughout. So it's either if you get a positive gradient or a negative gradient. That's it. So you must know that. But now let's understand what called, if we are to have an example there, if we have to have an example of a graph, let's say this graph is like this. I'm gonna draw the one with the positive and the one with the negative, with the negative a. So let's draw a graph of Okay. Okay, let's draw another graph here. Let's now say we have an asymptote there. Okay. Let's also have another one here. Okay. So let's say this graph here is y equals to -2 over x plus 6. Okay. This is the graph of y equal to, what is it? What is it? Maybe let's say 3 over x. Okay. So y equals 3 over x. And this is the graph that we have. Now, we want to know what the domain is. So let's start with this one here. Domain in this case here, domain, remember, is set of x values. But remember, we only have one asymptote where we are saying it does not touch x y equal to 0. It does not touch the x, what is it? What call y equal x equal to 0. The what called the y axis. So here our domain should be x element of real numbers. Then we now restrict it, but x must not be equal to 0. So it means that we can say, yes, we can say, what is it? It can occupy all values of x, but not x equal to 0. Now, remember, because it's an asymptote. Now, what about the range? Range, it's again y element of real numbers, but our y must not be equal to 0. Are we guys understanding each other here? Y must not be equal to 0. Yes, it can occupy all the values of y, but y cannot be equal to 0. Why? Because these two are our asymptotes. Okay, these are two our asymptotes. Now let's look at what called in terms of the decreasing. Where is it decreasing? Let's talk of decreasing here. It's decreasing where all set of values, all values. So it's decreasing. You can see that it's decreasing here, it's decreasing also here. The shapes are decreasing, you've got decreasing gradient. So in this case, you don't need to stress yourself. You know again that where it's decreasing, it's x element of real numbers. X element of real numbers, but x must not be equal to 0. Because we are saying in the y-axis, it will never touch. So that's why x is equal to 0. So it means that we are saying decreasing is decreasing everywhere. What about increasing? It's not increasing. This graph is not increasing. Now let's talk of what is it? Let's talk of increasing. So increasing here. Increasing, no increasing. No. Here it's no. Okay, so what about, let's look at this other graph here, the way we are saying it's -2 over x plus 6. Let's see what will happen here if we are to have what you're talking of domain. Now let's look of domain. What happened to the domain? Domain, remember guys, it remains like that. Domain does not change. X element of real numbers, okay, but x must not be equal to 0. But range changes. Range changes. Why range does change? It changes because it's based on the q. So in this case here, we are saying y is element of real numbers. But y cannot be equal to q, which is 6. That's how it works. So y cannot be equal to 6 because that's why it doesn't touch. But y can be any value except 6. So here, let's talk of the not equal and also not equal. Sorry about that one. I didn't put not equal. Not equal, so you equal, then you slash, then that's what it means. Then let's look at the increasing here. If this graph is increasing, so it's increasing only. So if they are to set the values of where it's increasing, you know that, oh, this one does not stress me. Stoller told me it's element of real numbers, but x cannot be equal to 0. Yes, it's element of real numbers, but x cannot be equal to 0. That's what we know. That's where the graph is increasing. Because here, the gradient here is positive, the gradient here is positive. So that's what you need to understand here. Let's move on to the next one, where we are finding the equation of what called given a point and q. Now, q is actually given to you. So what do you need to do here when you're given that? Let's have our equation here. Y equal, let me use another color there. Y equal to a, so in this case here, a over x plus q. But now let's see what we have. We are given q is given. What is q? Is -4. And a point is what? It's 2 and -6. So this is more like we are given we're given x and our y. Okay, that's what is given to us. So what are we going to do? We're going to substitute y is equals to -6. -6 is equals to a over what is our x is 2. What is our q is -4. So in this case here, we are looking for a. So let me just put a there so that we know that we are looking for a there. Now, then from there, we take multiply. We can take -4 that side. It's going to be negative, -2, -4, 6 plus 4. It's going to be -2. Is going to be equals to a over 2, which is going to be equals to a is going to be equals to -4. So our a is equals to -4. So how do we write our equation now? Our equation is therefore y is equals to -4 over x -4. That's how the equation looks like. Okay, because we are only looking for a here. That's all. Now let's move on to the next one, where we are actually to find again the equation. But in this case, we are given a point and the axis of the axis of symmetry. So here we're given the equation and the axis of what? Symmetry. Now, line of symmetry, we must understand that line of symmetry give us q. So here in this case, we are given q. Let me just we are given q in that case. We are given q, and q is 7. That's what you just need to remember there. You must pick that q in from there. So what is given to us? We are looking for the equation y equal to a over x plus q, where we are saying our q is given as 7, and we also have a point which is -3 and 4, and that from -3 and 4, that should give us our x and y in the equation. Okay, so now let's continue with our equation here. We're gonna say, okay, what is y? 4 is gonna be equal to a. We are looking for a in this case, so we can just put another color there for a. Okay, then we see a over what? A over x, which is -3. Plus 7. So if you have to take 7, that side is going to be -3 is going to be equals to a over -3, which we multiply both sides by -3. A is going to be equals to +9. So in this case, our equation in this case will be equals to y is equals to 9 over x plus 7. So we can also see that the 9 is positive because it's in the graph is in the first quadrant and third quadrant. Okay, so that's all what you need to know, these guys. That's all what you need to know about this. Don't forget to subscribe on our YouTube channel, and also follow us on Instagram, Facebook, and TikTok. Thank you so much. Until next time.